6.4 is on page 338, talks about method of variance of parameter, but now we're talking about a general of any order linear differential equation. So consider the nth derivative of y, make sure that's a 1, plus some function times the 1 derivative less, all the way to the constant y, no derivative meaning, plus will equal a function of g, or g of x, if p, q all the way, these are continuous on some interval, and if y sub 1, y sub 2 all the way to y sub n form a fundamental set, meaning those are from the complementary solution, then the particular solution is going to be, and here you need to modify whatsoever, you just use the formula and that works, that's going to be y sub m. These are the homogeneous, g of x is right there, w sub m, so the Wronskian, and keep in mind you find Wronskian by listing n by 1. I should say yeah, that's fine. So that's slightly different than what we did before. We did the s and we evaluated from t naught to t. Now we're just going to jump straight at it and make it dx. It's a lot easier this way. So let's look at a problem and see how this applies. Here's a problem. So g of x is actually x. We got that. Now we want to find the solutions, the y's, so we could use that formula properly. Let me copy this formula down. Oh boy. Just want that part. No, okay. This okay. Copy it. There we go. Much better. And I'm going to shrink that so we could just see it. Well, how does this work? I need to figure out the solution first so I can get the Wronskian. Well, the complementary solution, by the way, this is on page 341. Okay, so r cubed minus 2r squared plus r equal to 0. Factor an r out, and that will be r minus 1 squared equal to 0. So we have r equals 0, e to the 0 is 1, r equal 1, e to the x, and x e to the x. Those will be the y's. The Wronskian is going to be 1 to derivatives, e to the x, take a derivative of that, that's the same, x e to the x, take a derivative of that, 1 times e to the x plus x e to the x, take another derivative, e to the x, and the derivative of e to the x is right there. So there's the Wronskian. I pick the first row, that's 1 times cross its row and column, that is e to the x, that's 2 of those. So e to the x times 2e to the x is 2e to the 2x plus x times e to the 2x minus e to the 2x plus x e to the 2x. So I have 2e to the 2x minus e to the 2x, that's 1 e to the 2x, x e to the 2x minus, that cancels out. That's the Wronskian with all of those. Now I need 3 of those. W sub 1 Wronskian associated with 1, will 0, 0, 1, and copy the last two, e to the x, e to the x, e to the x, x e to the x, e to the x plus x e to the x, and 2e to the x plus x e to the x. And that's going to be 1 cross its row and column. That's going to be e to the 2x plus x e to the 2x minus x e to the 2x. So those cancel out. W sub 1 is e to the 2x. And if we go for W sub 2, the first row is 1, 0, 0, 0, 0, 1, and x e to the x, e to the x plus x e to the x, 2e to the x plus x e to the x. And if I pick a row or column, let's say I pick this, 1 cross its row and column, that's 0, minus e to the x minus x e to the x, and there it is. And if I go for the third, and if I pick this entry, that will be e to the x minus 0, which is e to the x. Got them. So I got everything that I need. And now I could say, according to this formula, the particular solution is going to be y1, so you plug 1 in, y1, the integral of g of x times w1 of x over w of x dx, plus let m equal 2, y sub 2, the integral of g of x, w2 of x over w of x. Of course, those are the Wronskian, and y3, because I have 3 solutions in this case. Well, let's see what we know. We know that w is e to the 2x in each of those cases. The first y I got, so it's going to be 1 e to the x and x e to the x. Okay, and if I look at g of x is always what's on the right hand side. In this case, it's an x. And I just figured w sub 1, they're right there. W sub 1 is e to the 2x. And w sub 2 is this mess. That is a negative e to the x plus x e to the x. Okay. And the last one, we got it to be e to the x. All of those dx. Okay, if I integrate those, I'll get the particular solution and I'm done. So the particular solution will be the integral. This is simply x dx minus, this is, oh, I see. Well, it's easier to do this way. X e to the x. Oh, wait. There should be a 2 there. That doesn't make sense the way it's written. Oh, x e to the x. Right. So here, if I distribute that, and I could say that's x e to the negative x plus x squared e to the negative x dx plus x e to the x, the integral of x e to the minus x dx. Now, if I really pay attention, I could save myself a lot of work. That is y particular. This is simply x squared over 2. That part is done. And I notice that if I take this piece, let u equal x, 1 and 0, dv be e to the negative x, e to the negative x, and e to the negative x. That's a plus, that's a minus. So that's going to be negative x e to the negative x minus e to the negative x. This piece, if I start with x squared, that will be 2x, that will be 2, and that will be a 0. Positive, negative, positive. So that's going to give minus x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x. That takes care of this piece. Plus x e to the x, and x e to the negative x is right there. Okay, whatever that works out to be, the particular solution will be x squared over 2 plus, actually, if I take e to the x, if I take e to the minus x out of each one of those, I'll have negative x minus 1 minus x squared minus 2x minus 2. If I take e to the negative x out of that, so I notice e to the x times e to the minus x is just a 1. And this is going to be negative x squared minus 2x minus x is minus 3x minus 3 plus these cancel out. I multiply those out. I get a minus x squared and a minus x. So my particular solution will be negative 2 of those. So 2 of those, that's negative 3/2 x squared minus 3x minus 3. Assuming I didn't make a mistake, that will be my final answer. So a bit lengthy, longer than we like. And I have another problem I want to do, the same deal. In this case, you would say, well, let's see. This is going to give r cubed plus r equals 0. R into r squared plus 1 equals 0. So r equals 0. That's a cosine of x and sine of x. Which means the particular solution is y1 times the integral of... Oh, I didn't figure out the Wronskian yet. The Wronskian in this case and this is sine of x, cosine of x, and negative sine of x. Sine squared of x plus cosine squared of x. The Wronskian is simply 1. W sub 1, 1, 0, 0, 1. So 1 times cosine squared plus sine squared is 1. So if I pick this row, 1 times 0, that's minus cosine of x. Alright, and w sub 3, okay, so I got them. And g of x is sine of x tan of x, so the particular solution is going to be y sub 1 times the integral of g of x times w1 divided by w dx plus y sub 2. We just did that. So the y's are right there. That's a 1, that's a cosine of x, that's a sine of x. The integral. G of x is sine of x. Okay, it should be in terms of theta, but we get everything should be in terms of theta. Let's make sine of x tan of x. This is a 1. So that's what's common in all of those. Now, here w of 1, we got it to be 1. W sub 2, we got it to be negative cosine of x. And w sub 3, we got it to be negative sine of x. Okay, I want to integrate those. The particular solution. The integral, what do you take a derivative of to get? It's not sine. It's secant tangent. So that is the secant of x. Here, that's a negative cosine. This is 1 over sine. 1 over sine, so 1 over sine times cosine. I'm sorry, that's 1 over cosine. Secant is 1 over cosine. Those cancel out, so I'm left with tan of x plus sine of dx. Plus a sine of x times the integral. Actually, the minus carries over. If I take the minus from the inside, oops. If I take the minus from the inside and put that right there, that becomes a positive. This is 1 over cosine, so sine over cosine, tangent times tangent is tangent squared of x dx. Now, identities are a must. So let's see how this works. Y particular is going to be the secant of x minus cosine of x. Again, it should be in terms of theta. And the integral of tangent is natural log of the cosine of x with a negative. Yeah. So with the negative, that should make this a positive. There you go. And this is nothing more than secant squared of x minus 1. So that is minus sine of x. What do you take a derivative of to get secant squared? Tan of x minus x. So the particular solution is secant of x plus cosine of x times natural log of cosine of x minus sine of x tan of x plus x sine of x. A bit lengthy of problems, which is why you only have 3 problems to worry about. And that's pretty much it for this section.